Hello, thank you for joining me today. We're going to talk about dividing decimals, and we call this decimal long division. The process that we're going to use is long division, and so I'm going to give you a bunch of examples today. I'll show you different uh, ways the questions can present themselves, and we'll talk about a couple of different issues, but the basics are we're going to take something divided by something else, and the thing that is being divided by, so in this case 3.312, is going to go inside the long division bar. So 3.312 inside that long division bar. And then the thing that's dividing into, or it's being divided by, goes on the outside, 0.92. Okay, that's step one, setting it up as a long division problem. And then step two is to take that outside number, that number that we're dividing by, and turn it into a whole number by moving the decimal over. So we're going to take that decimal, we're going to move it over to the far end of the number, and we're going to count the number of spaces that we move it over. So we move it over 2 spaces. What we're really doing is we're multiplying by 100, moving the decimal over 2 spaces. And if we're going to do that, we're going to do that with the other number on the inside. We're going to move it over 2 spaces also. So we're really multiplying. And if you think about it in terms of fractions, this as a fraction is 3.312 over 0.92. But if we take that fraction and we multiply the top and bottom by 100, we would get 331.2 over 92. And we would say, well, that's an equivalent fraction because we multiply the top and the bottom by the same thing. So that's what we're doing. We're just going to multiply the thing we're dividing into and the thing we're dividing by the same thing, with the goal of getting the denominator, or the thing we're dividing by, to be a whole number. Okay, that's just going to make this easier to deal with. Now, we don't normally rewrite the problem, but I'm going to do that for us, I think, just for ease of being able to see what we're doing here. So I'm going to make sure that I have all my digits with plenty of space. And here's why. Why do I need plenty of space? Because when you're doing long division, it's going to be really important that you have, let's do it a different way. It's going to be really important that you have columns. These columns are going to represent place values, and they need to be like very clearly lined up, like the numbers need to be lined up very clearly here. So we don't, I would never draw those columns in a problem that I'm doing, but I'm going to visually keep my numbers lined up really clearly. Okay, so you know that the first step we're going to do is we're just going to ask ourselves, how many times does 92, that's what we're dividing by, how many times does it go into each number in turn? So we start out with, how many times does 92 go into 3? And the answer is 0 times. We don't usually write a 0 there, but I'm going to do that just visually to recognize what we're thinking. Then we say, well, then how many times does 92 go into 33? And the answer is 0 times. So then we say, well, then how many times does 92 go into 333? 333. And the answer is, well, we have to make some guesses here. Right? So you say 92 is almost 100 and 333 is more than 300, so we would say at least 3 times, maybe 4 times, but probably not. So I'm gonna guess 3, and then I'm gonna multiply. And here's how I do it. I just write a 3 down here, and I just multiply. But I could have done this off to the side. So I get 6, and then 9 times 3 is 27. 276. And then just to make sure that I'm being accurate, I say, well, what if we did 4 times 92 instead of 3 times? So another 92 here. Well, that would be 6 plus 2 is 8. 7 plus 9 is 16. Carry the 1. That would be 368. So 4 times 92 is 368. That's too big. There's not 4 92s in 331, but there are 3 92s in 331. So I was right. I kind of knew that this was the right answer. So now notice that I've used up this space here now. I can't use it anymore. It was useful for me to multiply 92 times 3, but now I can't use that space anymore, so I'm going to have to erase this. Okay, so now I'm going to come in and I'm going to say, all right, so 3 times 92, oh, I erased it, oh no, I should have written it off to the side. That's 6, and then 27. So 3 times 92 is 276. So now I'm going to subtract 276 from the 331 and see what's left over. When I subtract, I have to borrow from the 3, make it a 2, make that a 1. So this is 11 minus 6 is 5. So 2 minus 7, again, can't do that, so I have to borrow. It becomes 12 minus 7 is 5. And then 2 minus 2 is 0. Okay, so 55 left over, clearly not more than 92. So there was only 3 92s in 331 with 55 left over. And then we bring down the next digit. So I'm going to bring down the 2. And I do this whole process over again. I say, how many times does 92 go into 552? Now, it's either 5 times or 6 times, right? Because 592 is almost 100. 552 is more than 500s, 500s. So maybe 92 goes in 5 times. Let's multiply that. 5 times 2 is 10. 5 times 2 is 45. Plus 1 is 46. 461. Or 460. But 460 is quite a bit smaller than 552. So I'm wondering if 92 goes into 552 6 times. So I'll try it. 6 times 2 is 12. Carry the 1. 6 times 9 is 54. Plus 1 is 55. Oh my goodness. It goes in exactly 6 times. 552. And so when we subtract here, we're going to get 0. So 92 goes into 331.2 exactly 92 goes into 3,312 exactly 36 times. But that's not what the question is saying. The question is saying how many times does 92 go into 331.2? And so we need to remember those columns. We need to keep or maintain the decimal place right where it was. So the decimal point was there. It needs to be there in my answer. So 3.6 times is the answer, 3.6. And that is long division with decimals. Okay, that's a lot of work. I'm going to work through, I'm going to kind of puzzle my way through several more problems here. This is how we do it. Let's see if we can come to another example. I should note that the only thing that was odd about that problem was the fact that it came out to be an even number. More often than not, these answers are going to not be even, not going to go in perfectly. Okay, divide 0.0453 by 0.98. Now, divide by, so we're going to put the 0.98 on the outside, and we're going to put the 0.0453 on the inside. Going to try to keep very clear columns here. And we're going to move the decimal over, and this time I'm not going to rewrite the problems. I'm just going to go ahead and do the decimal over 2 spaces. This is how you would normally do it. I'm just going to make my decimal point really big. Put my decimal point up here for the answer, really big. And now my problem is, what is 4.53 divided by 98? Okay, let's go back to look at the problem first. Remember when we were multiplying, I said it was always a good idea to just kind of do an estimate here. So I'm dividing something by 0.98, but think about this, 0.98 is really close to 1, right? It's just 2/100ths away from 1. So I'm dividing something by 1. So I expect that the answer is going to be really, really close to 0.0453. It's going to be close to that. So let's see if that bears out. So we've got a whole bunch of columns here with zeros in them. Obviously 98 does not go into 0. It doesn't go into 0. And it doesn't go into 4, but I'll put a 0 there 0 times. 98 goes into 4 0 times. I'll put a 0 there just to kind of get my placeholder for my decimal. My decimal is going to be there. And then I'm going to say 45. 98 goes into 45 0 times as well. But 98 goes into 453 several times. I would say 4 times. Right? 98 is close to 100. 453 is more than 400. So 4 times. I'm going to take my 98 and multiply it by 4 off to the side. 36 plus 3 is 39, so 392. And we'll subtract, get a 1 there, we'll borrow, and we'll get a 6 there. And so now we have a situation where we have our answer, but we've run out of digits, we've run out of numbers to divide into, but we have a remainder here so that we're not done. And we're not going to do that thing back in the day, back in grade school, where we used to say remainder 61. We're not going to do that. We'll do that again in algebra, but not here. Instead, what we're going to do is say, well, the decimal number 4.53 could be written as 4.530, right? The numbers don't end just because we run out of digits that are not 0. We've got a bunch of zeros here. So I can bring down another 0, and I can create another column, and I can just keep on going. So how many times does 98 go into 610? I'm going to say about 6 times, so 98 times 6. 6 times 8 is 48. Carry the 4. 6 times 9 is 54, plus 4 is 58. And that sounds about right, so 6 times 98 is 588. That's less than 610, which is good, but it's really close. It's as close as I can get to 610 without going over. So now I'll subtract. I have to borrow from the 6, make it a 5. Make this an 11, borrow from the 11, make it a 10. Add a 10, so 10 minus 8 is 2. 10 minus 8 is 2. 5 minus 5 is 0. So there's a 22 left over. Okay. And we could keep on going. And maybe I will just one more round just to see what happens. So bring down the 0. How many times does 98 go into 220? Well, probably 2 times. So put a 2 up here. 2 times 98, let's see, that's 16. That's 19. And again, we can subtract. We're going to get a 4, and then we're going to get 2, 24, 24 left over. So we can keep on going as long as we need to. So in order to kind of save ourselves from going too long, we're going to need to read the question again. And it said to round, this was the clue that the answer wasn't going to be even. Round the quotient, round the division problem, so that round the answer to the division problem to the nearest thousandth. Okay, so we have to remember our place values. Remember, this is the ones place is before the decimal point. The tenths place, tenths, T-E-N-T-H-S, tenths, and then we have the hundredths, and then the thousandths, and then we have the 10,000ths. Okay, so the thousandths place is the 6 here. So we're going to round to that place, 3 decimal places. And in order to round, we have to know the number after it. So I needed to know this 2, so it's good that I kept on going. We needed to know the 2 so that we could decide whether we're going to round up to 0.047 or if we were going to round down, keeping the 6 and just dropping the 2 there, to 0.046. So the 2 is less than 5, so we're going to just drop it, and the answer is going to be 0.046. 0.046. Now let's think about that. We said that if we divide something by a number that's really close to 1, then it doesn't change the number that much, right? Divide something by 1, you just get the same number. Here we divided 0.0453 by 1, a number just a tiny bit less than 1, and we got an answer that's just a tiny bit bigger than 0.0453. We got 0.046. So this checks out. It meets our logic test that says that maybe we made some small mistakes here. We haven't made any big mistakes on this problem. Okay, that was tricky. Should we do another one? I've got like 3 more, so this will be a long recording. You can watch as long or as little as you want. You can watch at high speed, but this next one is the shortcut problem, so I want you to watch this one for sure, and then if you feel like you understand long division, you can quit. I'll do the last 2 fairly quickly. Okay, so the shortcut is remember when we're multiplied by a factor of 10, so a 1 with any number of zeros after it. It was easy to do that because you just move the decimal point. It turns out that when we divide by a factor of 10, we get the exact same thing. And I'll show you in long division form. So 1, 0, 0, 0, 0 goes into, and then I'm going to do 13.49. Okay, so I'm dividing this in. Now, you would never do this. You would never do it this way. But imagine, right? If this had been a decimal, if there had been a decimal point over here, I would have moved it over to the 1, and then I would move this decimal point over as well. But if there's a decimal point way out here and there's a bunch of zeros, like unnecessary zeros, we don't need those zeros there, then I'm going to move the decimal point this way, and I'll do the same thing with this decimal point. So I'm going to move the decimal point 1, 2, 3, 4 spaces. So I'll move this decimal point 1, 2, 3, 4 spaces also, and put my new decimal point right there. So this becomes 1, right? I crossed off all those zeros. And then what does this number become? Well, I moved the decimal point from where it was between the 3 and the 4. I moved it to the left 4 spaces, but there was only 2 spaces to move it. It was just to move it past the 3, move it past the 1, and then there was like 2 more spaces that I didn't have. And that's where I need to put zeros. So 0.001349. So now I'm dividing by 1, and of course anything divided by 1 is just itself. Oops. And that's the answer. Now, 2 things I'm missing. Number 1, we would never do this in a long division form. We would just look at this and say, well, if I'm dividing by a number that is a factor of 10, anything with 1 with a bunch of zeros after it, I'm just going to move the decimal point that many spaces to the left. I'm going to make it smaller because when I do division, I'm making things smaller. So I'm going to move the decimal to the left as many spaces as there are zeros. And again, I have to put in zeros at the front of the number to give me the spaces to move over the decimal point. And then we still have to follow the rules of positive and negative numbers. If I multiply or divide a positive by a negative, or a negative by a positive, the signs are different, then the answer is negative. So the answer is going to be negative 0.001349. Okay, that's the shortcut for division. If you're dividing by powers of 10, it doesn't come up very often, but when it does, this is much easier than doing long division. Okay, let's do a couple more problems here. Divide negative 35 by negative 0.0007. The first thing to note is that we're dividing 2 negatives, so the answer is going to be positive. So the answer is positive. So I'm just going to write that down, and then I'm going to ignore the signs from now on out, so I don't need to worry about that. We're dividing a number which is 35 by another number which is 0.0007. Obviously, that is a decimal number. We want to move the decimal place over so that this is no longer a decimal. And that's 4 spaces. So we're going to move my decimal point at the end of the 35, 4 spaces over, 1, 2, 3, 4. Put the decimal point right there. There were no spaces, so I have to insert zeros. And now I can do this math. I can cross off all these zeros, and so I'm just dividing, what is that, 350,000 by 7. Well, 7 that goes into 3 0 times. It goes into 35 5 times. 5 times 7 is 35. I subtract to get 0, and then I bring down the 0. 7 goes into 0 times, and then bring down the next 0 times, and it goes into the next 0 times, and the last 0 times. And now I'm at the decimal point, so I can stop. So the answer is 50,000. This is a really good example because it shows us a problem that is really, really easy, but because it's easy, we tend to mentally try to make it harder. So it becomes easy dividing into 0 is really, really easy. So don't be fooled by that. Okay, let's do one last one. I think this will come out well. This will be a good example to end on because, again, we're going to round to the nearest. This time we're rounding to the nearest 1,000, not thousandths, but the nearest 1,000. We're dividing 200 by 0.054. So the first question I have is, how am I going to round this to the thousands? And I'm not even, there's no thousands, it's a 200. But we can see that as soon as I move the decimal over 1, 2, 3 spaces, that's going to make my numbers much bigger. So I'm adding 3 zeros at the end. Now we can clearly see that this is 200,000 divided by 54. And so very possible that we'll get an answer in the thousands here. Okay, so how many times does 54 go into 2? 0 times. How many times does 54 go into 20? 0 times. How many times does 50 go into 200? Well, uh, 50, 54. 50 goes into 200 4 times, but 54 probably goes in something less. So let's say 3 times, right? Because 50, 2 50s is 100, 4 50s is 200. So, but this is 54, so 4 54s would be more than 200. Okay, so 3 times 54. Let's do that off the side. 54 times 3, we need to make sure. 3 times 4 is 12. Carry the 1. 3 times 5 is 15. Plus 1 is 16. 162. It's less than 200, but if I added another 50 to that, it'd be more than 200. So we're stopping there. We borrow 1 from the 2, make that 10. Then borrow 1 from the 10, make that a 9. 10 minus 2 is 8. 9 minus 6 is 3, and 1 minus 1 is 0. So there's a 3 there in the thousands place. And bring down the next digit, the 0. How many times does 54 go into 380? 380, well, let's see, there's 6 50s and 300, 7 50s and 350. So I'm going to guess 7 times. Let's try 54 times 7. 7 times 4 is 28. 7 times 5 is 35. Plus 2 is 37. So looky there. 7 times 54 is 378, which is almost 380, but just not quite. So when I do my subtraction, borrow from the 8, make it a 7, add a 1, 2, everything else cancels. So 54 goes into 380 7 times with 2 left over, and we can now move down the next 0 if we want to. But remember that the question said round to the nearest 1,000. So I have, this is the ones place, the tens place. I haven't even got those numbers in yet. This is the hundreds. And this is the thousands place. So we're going to round to this place. So that means we only need to know the next number over, which is 7, and that tells us if we need to round up or round down. And of course we're going to round up because it's greater than or equal to 5, so we're going to round this up to 4,000. And notice that I didn't even have to figure out how many times 54 goes into 20, which would be 0 times, and then how many times 54 goes into 200, which would be 3 times. Right? I didn't need those digits in the ones and the tens place, so I didn't have to bother calculating them because I was told to round to the nearest thousands. So the answer is approximately 4,000 times. Obviously that's been rounded up, so we're kind of uncomfortable with this, but that's what the question told us to do, round up to the nearest thousands place. Thank you very much for watching. I know this was kind of a long one, but hopefully you watched it at double speed, and have a great day.